Today's video is dedicated to developing an intuition of aromatic substitution reactions. So we'll talk about how to add different things on benzene and how to manipulate it through different reactions. Okay, so first, if you want to add an alkyl onto benzene, you can use a Friedel alkylation. So this method basically adds a secondary or tertiary alkyl onto the benzene ring. So the carbon immediately bonded to the benzene, this one is going to be secondary or tertiary, okay? However, if you want to add a methylene group, that is the carbon directly bonded to the benzene is primary, if you want anything primary, such as this, you cannot just use the Friedel alkylation, but you will need the Friedel acylation. So the difference is you will use a carbonyl in your reactants, but the products we want usually don't contain the carbonyl. So the next reaction that usually follows this step is a Wolff-Kishner reduction, which essentially just removes this carbonyl and gives you back the product that you would like to get if you were just doing an alkylation. So the Wolff-Kishner reduction, but you can also use a Clemmensen reduction, but we see Wolff-Kishner a little bit more often. It looks like this. There's NH2 twice, and there is a base. You don't have to write potassium, and in the presence of heat. So it's all just one step. This is a Wolff-Kishner reduction, or you can use a Clemmensen reduction, which is zinc, bracket, mercury, and some acid. Okay, so it's up to you, but I like the Wolff-Kishner. Now, let's talk about the reactants involved. Of course, there's a benzene, but we want to add an alkyl onto the benzene. So there's going to be an alkyl. You can have a secondary or a tertiary alkyl, and there's going to be a chlorine leaving group. Okay, whereas for Friedel, it's the same thing. You want whatever alkyl you want to add onto the benzene, but you also add a carbonyl on it, and of course our chlorine still gotta be there. Okay, so let's say if we had this picture added onto our benzene, it would look like this. So this was where our chlorine used to be. Now this is our carbonyl, but then if we put it under Wolff-Kishner reduction, it basically removes this carbonyl and gives us a primary carbon directly attached to a benzene. Okay, and both of these reactions are done in the presence of this Lewis acid. It can be another Lewis acid. The point is this has an incomplete octet. Okay. Another reaction that involves using this kind of incomplete octet Lewis acid is if you just want to add Cl2 or Br2 onto your benzene. Now we don't say it's addition because benzene does not undergo addition, but it is a substitution reaction. But we'll review this later in the video. Okay, so that's how you add alkyl branches, secondary, tertiary, or primary. Those are the steps and reactions. Now, there are other options of adding a branch onto your benzene, and that is through, you don't have to use an alkyl branch plus leaving group if you want a secondary or tertiary alkyl. Okay, this is only for secondary, tertiary. You could also start with alkene or alcohol. So the point is here, alkene plus acid, that will give you a carbocation, which might rearrange. Okay, whereas for this one, this is acid catalyzed elimination. Acid catalyzed, yes, yeah. So the point is, this OH and this acid will basically react and give you a carbocation, and it might rearrange or it might not, and that will give you your secondary and tertiary alkyl branches onto your benzene. Okay, so you can use an alkene, an alcohol, plus an acid. Now, Last, let's talk about the cherry on the top. This is like the most important step, and then after you might want to modify what you have. So let's say if you want to add carboxylic acid, okay, carboxylic acid, you can use the side chain oxidation reaction. So the first step involves this, and the base, and then the second step involves acid. So make sure to separate these two steps, because if you put these two steps together, that will just give you water, which is not helpful. So that will give you benzoic acid if you're starting with some alkyl group. Okay. Another option, once again I told you, if you want to add just a chlorine or a bromine on it, you can do your halogenation thing, but also this is not addition reaction, it's substitution, so use some kind of Lewis acid with an incomplete octet. If you want to add an alkene onto your products from Friedel crafts, you can add a halogen on it and then use elimination to get your alkene. And a good way to add your halogen would be through the radical reaction. Okay. And for elimination 2, you can use terbutoxide or another base. And lastly, if you want to add another type of acid onto your benzene, such as a nitration or sulfonation, you would use a strong acid plus your HNO3 and SO3H. Now the only thing I would warn you is when you add HNO3, your product is not in HNO3. That's not what you add on the benzene ring. You actually just add NO2, okay? So this disappears and this disappears, whereas if you're using sulfonation, you add it directly at SO3H onto benzene. Now, if you need to draw the electrophiles of these two reactants, these are what the electrophiles should look like. The first one is the nitronium ion, and the nucleophile that results is H2O, so there's another reaction on that. You just need to learn the steps, but this is a nucleophile, and essentially benzene's alkene attacks the positive charge, negative attacks positive, but that must mean to maintain the octet rule, this double bond gotta go onto the oxygen. So that's how you get NO2 bonded to benzene. And for the bottom, once again, the alkene attacks the electron deficient area. This has incomplete octet, so it's acid. And to maintain the octet rule, this alkene's got to go, and it usually likes to go wherever it's positive. So that's how you would also get your SO3H bonded to the benzene and your NO2 bonded to the benzene. If you ever need to draw it out, beware your product is going to be one double bond and one single bond, and then here it's going to be 2 double bonds, 1 single bond, and the H. Okay, so just watch out for how the double bonds might change when you undergo the electrophilic substitution with benzene. So I hope this video was helpful. If it is, make sure to hit a like